Hello everyone, welcome in this new program where we are going to dive into most beautiful item for each query. So basically we receive as input an array of arrays where each of the elements is actually a price and the beauty, right? And then after that we receive a query which is an array of integer, and for each of the query we are supposed to find out what is the maximum beauty of an item whose price is less than or equal to a given query. Let's say you have this, for instance. If you receive as input, let's say 2, what is the item that has a price less or equal to 2? What are the items? You have this guy and this guy. Those are the two items with a price less or equal to 2. And among those items, which one has the biggest price? In fact, which one has the biggest beauty? The biggest beauty is 4. That is why query of 2 is actually 4. And that is basically what you're supposed to do here. For each of the query you are going to receive as input. There's a straightforward implementation of this, which is using an n square approach. I'm not 100% sure this one will pass, so I will not implement that. I will directly go to another approach, which is a little bit clever. So what I will do is that this is my initial array that I have here. The first thing I will do is that I will sort the array. Why am I sorting the array based on the first element? Because I want the one with the smallest price to be in front, right? And once I have this, I'm going to split this into two different array of price and array of beauty. So I will say this is my logic of splitting. I will say the first element like this is going to come here with price 1, beauty 1. The second element like this is going to be here price 2, beauty 4. Perfect, right? The third element is going to be here, but it doesn't make sense for me to put a beauty of 2 here. Why? Because this one already has a beauty of 4. That means if I'm searching for an element with a price less or equal to 3, the beauty should be at least 4. So I'm going to compute a maximum of 4 and 2. So this one will be 4. Make sense? Now this one has the same value with this, so I don't want to have duplicate prices. So to fix this, when you have an element that has already been in your array, you just need to compute the maximum value of the value of the incoming guys and the current one. So in this case we are just going to erase this 4 and insert put a 5. Make sense? So now we continue, and then after this there is no 4, so we just have a 5, and then we have a 6 here. So now how are you going to use this? This will be interesting in the sense of, in this array you can apply binary search on the query, and once you have the iterator, you can directly have the index and find the corresponding value here. What does that mean exactly? Let me, for instance, if I'm searching for a query of 1, what I would do is that I would check for the first element which has a value strictly greater than 1, and I'm going to 4 here. And after this I'm going to take the previous element, because the previous element will be something less or equal to the target, because what I searched for was the one bigger. So I'm going to fall into this guy, and when falling into this guy, I'm going to compute a distance, like to find the index of this guy, which is actually 0, and I'm going to find the beauty of that index, which is actually a 2. That's why here the first element is 2. You are going to do the same for query of 2. Query of 2 will actually give you this guy, this index, so it's going to return 4. Query of 3 will actually give you this guy, which is falling to this index, and this is going to return 5. Query of 4 will actually give you this guy same, so that's why it's 5. Yeah. And query of 5 will actually give you this guy 6, and query of 6 will actually give you another 6. That is why you have the 2 4 5 5 5 5 5 6 6. That's why you have this, which is the answer. So now that being said, what will be our approach of coding this? I'm just going to go with an implementation directly of what I've just explained here. So the first thing I will do is that I will sort my items. Sort my items, After sorting my item, I'm going to create the vector of, I just mentioned, the vector of price, the vector of beauty, and I need to have a vector of ans that will return here. Is the guy I will return here. And in here, what I will do is that I will just create this vector of price and beauty first. That's the first thing I'll do. How do I create my vector of price and beauty? I'll just first initiate my price the pushback of of item of zero, which is actually normal, and then I'll have beauty dot pushback of item of 0 of 1. So what I'm doing is that I'm taking the first element and I'm filling the first row of beauty and price. Now that I have those elements, the second thing I will need to have is to have my for loop moving from 1 and for each of the elements I just need to check if the items dot I dot 0 is actually equal to price dot back. So this is the case where you don't need to add a new element like this. When you're facing this one, you don't need to add a new element, you just need to update the beauty of the last element in this scenario, in this specific scenario. How do you do that? So you just need to say beauty dot size -1 will now take the marks of items of I of 1, that is the new, this is the new beauty, and this is the previous beauty. So this is all what you need to do here in case you are coming with a price that already exists. In the other scenario, now you need to push new value. You need to push the new item, the new price, which is item of I and 0, and then you also need to push the new beauty the push back of items of I 1. But just that when you are pushing a new value like we did here, you can find yourself with a value but you don't use this because the previous one is actually bigger, so you need to compute the maximum here. So what you will do is that is the maximum of the incoming item and the beauty dot back. Perfect. So I'm missing one cluster. So this is actually enough to create this. Once I have this, I'm almost done. I just need to have my second for loop here for int query of queries, and for each of the elements what I will do is that I will first use upper bound to find the element with a value strictly greater than the query. So I'm going to have auto it is going to take upper bound of price that begin price that end. What am I searching for query and upper bound. Once I have this, I'm just going to check if the iterator is actually equal to the price that begin. That means there's actually no item with a price less or equal to the given input, and in this specific case it doesn't specify that we should take 0 for the scenario. So if it is actually equal to the price that begin, what you should do is that you should just add a 0, that's all. And otherwise you now need to add a special element. Let me show you how to do that. So first of all, you compute. Don't forget that it is actually the iterator to the element which is actually greater than the query. So the really element should be, we are going to take in beauty, the really element is it -1, or the really iterator, and now you should make the minus begin to have now the distance in between minus price that begin to have the distance in between the it -1 and the price, and that will give you an integer that can be used to index the beauty array, whereas the it is coming from the price array. That is why we splitted this. Okay, nice. So once you have this is all. Let us run and see. Okay, perfect. Working properly. Let us submit. Yeah, performing pretty well. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new video, new challenge. Ciao.